If you have any objections, please let me know. So Marcos, you can start.
Okay. Hello, everybody. So today, as usually said, it's the final webinar of the Artistic and Digital Skills section of webinars. And we are going to talk about the 3D printing hardware and software. I'm sharing my screen right now, so we can all start together the process. All right. If there is any problem regarding the sound or the video, please let me know. So, this is the project consortium, as you may know from the previous webinars. As I said, this webinar is regarding the 3D printing hardware and software. And we are going to go through some things like the FDM printer hardware. So these are, let's say, the basic titles of the whole webinar. We're going to talk about slicing a little bit, how we can print a model, a 3D printed model. So we're going to go through the whole process of using a 3D printer and basically adjusting everything in order to create a perfect print, and then how we can post-process the model to create something looking professional. All right. So first section is the FDM printer hardware. And as I'm writing down, let's see what an FDM printer is made of and how it works. All right, this is the printer that we're going to talk about today. It is the Tivo Tornado, which is an affordable large volume 3D printer made by Tivo. Tivo is a manufacturer based in China. And the Tivo Tornado comes mostly assembled, requiring minimum assembly by the user. It has an aluminum frame, as you can see, which provides a very sturdy structure. And basically what the Tivo advertises regarding the printer is a smooth and precise 3D printing, the 3D printed parts, thanks to the Tivo V-slot linear guide system. Now, more specifically, as you can see on the right side, the printer can print a model with a maximum size of 300 by 300 by 400 millimeters, which is bigger bigger than most entry printers out there. Its extruder is a full metal 3D Titan printer, 3D Titan extruder, which means that we can use material types as PLA, ABS, and PETG. You may also with PLA, PVA, and flexible filaments. So you may also remember those filaments from the previous webinar that we discussed about them more specifically. The nozzle size of the Hotend is a standard 1.75 millimeter nozzle, and also it can print one color each time. And its position accuracy on the z-axis is 0.004 millimeters, while on the x and y axis it's 0.12 millimeters. Now, at this point, I would like to mention that the position accuracy of a printer is one of the most important functions that define the cost of a printer. For example, a Tivo Tornado costs roughly 30 to 40 euros, for example. Now, if the position accuracy was doubled, it would probably cost more than 1,000 euros. So the precision and the accuracy of a printer is one of the key factors when you decide to buy one. Let's talk about the frame. In the pictures, you can see the frame of Tivo Tornado highlighted with yellow lines. The frame of a 3D printer is a very important part. It may look simple, as you can see, but the design can actually be quite complex. This is due to many different design possibilities. The importance of the frame is attributed to the following. It supports all the mechanical and electrical components that carry out the actual printing work. It determines the build volume of the 3D printer, and it gives the printer the robust look as well as the aesthetic appearance, as you can see. So, when choosing a 3D printer frame, one has to consider the cost, the ease of assembly, the strength and the durability, as well as the application in terms of desired build volume. Now, aesthetics may be a great consideration to designers and businesses who may want their printer to look good and presentable to the public. However, it may now not be an issue to printers solely used to experimentation or basic prototyping. For example, me, I'm not a designer or a business, so I don't really care about the looks of the printer. So I can use something like this. Now, if you search the internet for FDM 3D printers, you may notice that most of them have aluminum frames or steel frames, which look like the one on the picture on the left here. Those provide durability and vibration resistance. This is why most manufacturers decide to use this type of aluminum or steel profiles in order to create the frames of their 3D printers. Oh, sorry. Now let's talk about a little bit about the heated bed. Early 3D printers didn't have heated beds. To encourage prints to stick to cold surfaces, materials such as the painter's tape, as you see, were used to improve adhesion. It didn't take long, however, to realize that most materials bond better to a warm print surface, and that this also brought several other important advantages. FDM printers extrude molten plastic at a temperature high enough to allow it to flow, but low enough for it to cool and resolidify in a predictable way. However, if cooling happens too quickly, or the extruded filament reaches too low of a temperature, it contracts too much, internal stresses build up, and adhesion and warping issues start to occur, especially at the interface with the printing surface. And that's why the heated print bed should be in a high temperature while printing. All right. Now let's have an inner look onto the components that the heated bed is made of. As you can see in the first picture, the surface of the heated bed stands on the steel base. In the middle picture, you can see the main component of the heated bed, which is the hidden surface on the bottom of the printer. And you can see there the way that the heat is transferred to the surface. So basically what happens here is that those parts that look like batteries with the yellow color, these are called heaters. And as you can see, we can supply those shooters with those heaters with electricity through those cables. And since they are attached to the surface, they transfer the heat to the surface. Now, keep in mind that these steps take a little bit of time, so let's say 2 to 5 minutes, in order to bring the surface to the desired temperature. Moving on to the next slide, we can see some types of covers for our surface. Now, the most common one is the glass cover, which is simply a glass surface added on top of the heated surface, so that we can extract it when we want to, and take it out with the 3D printed part, cool the temperature, and this way it's much easier to take out the 3D printed part. The glass cover. Sorry, I didn't talk about the magnetic. So we also had the magnetic cover, which is also very easy to extract and take out from the standard surface. And we have the mirror cover, which is basically the same as the glass cover. Now, the glass cover and last, the glass cover, in my opinion, is not the easiest one to use. If you are an entry level, a newbie, let's say, in 3D printing, maybe it's better to go with a magnetic cover, because you don't have to do the whole process of trying to create the perfect adhesion in the bed for the 3D printed model to stick onto. So choose the magnetic cover when you start 3D printing, then decide if you want to go to the glass cover or the mirror cover. Now, since I already talked a little bit about the adhesion stuff, let's see some adhesion solutions. So if you decide to go with the mirror instead of the magnetic bed cover, then you may also decide to use some of those techniques. Some of the most standard products that people use in order for the model to stick on the top of the bed is a classic glue. Here in Greece, we have the standard Uhu stick glue. I don't know if you also have it on your countries, but this is the most commonly known one. Another way to help your model stick on top of the bed is with the use of duct tape, of course, as we saw on the previous slides. And my personal favorite is the hairspray, because it is the fastest one, and also there are special sprays in the market, like the one shown in the picture, that are used just for this reason, which doesn't stick anywhere, but it does a great job when it comes to the adhesion problem. Okay, so yeah, this is my personal favorite, and this is the one that I would suggest. Now, if you go with this choice with a hairspray, keep in mind that you will have to cover your fans, your printer fans. So it's better to keep your 3D printer closed when you put it on, and when you are ready and you know that all the particles of the hairspray are not there anymore, then you can use the fan. All right. Now, As we've already said, in order for the printer to print a 3D model, we need to actuate three axes, the X, Y, and Z axis. The X and Z axes are actuated on top of the bed, where the hotend is, but the third one, the Y axis, is actuated on the bottom, over the bed. Now, let me show you the first video in order for you to understand, okay? This is the Y axis. And this is the motor, which works when the printer is on in order to move the print bed on the front or to the back of the printer. Now, let's talk a little bit about the nozzle or the hotend. No, sorry, the nozzle is this part, and the hotend is the whole component, which also includes the fan and the inside components. Now, the hotend is one of the most important components of the 3D printer. As it hits the filament, it pushes it through the attached nozzle. It extracts it in a liquid form on the bottom and starts printing the model. Hotends are usually very durable and conductive, and they are metal designed print. Sorry, they are constructed by metal, consisting of a few elements, which we will see on the next slide. In my opinion, the hotend is a very critical component of a 3D printer, and issues in this area can be significant, can have very significant effects on the final print. The most common issue, for example, is the clog of the hotend, which can lead to incorrect extrusion or no extrusion at all. And the common cause of hotends is heat creep, where heat climbs behind the melt zone, and a hotend and material melts too early, blocking the filament path. Now, this is a much easier, a much better representation of the hotend. So here I can show you much easier what happens here. So the heat creep is basically that the printed filament goes through, and since it is very high here, it starts to liquidify on this point, and then it stacks on the nozzle. It doesn't go through. You still push it with the extruder, and the clog occurs. So your print basically fails. Now let's see the standard procedure, the one that should happen. Before deeply analyzing the main aspects of the hotend, some aspects of plastic filaments need to be taken into account. First of all, plastic is a combination of a polymer and additives. A polymer can be described as a material made of long and repeating chains of molecules. All these chains can modify their viscous behavior depending on the temperature. At this point, in most of the polymers, there are two critical temperatures: glass transition temperature and melting temperature. Glass transition temperature, or else TG, is when a polymer is in a semi-crystalline state and its chains have no mobility. Beyond the glass transition temperature, it turns to a rubbery state, expanding itself, and the chains gain some mobility. Then we have the melting temperature, which is another transition point where the polymer, or else let's say the plastic, okay, so polymer is basically the plastic filament, turns from solid to liquid, so it can be extruded easily as the chains break. So what happens here is that the filament is fed through the nozzle, while at room temperature, starts heating up while going through the PTFE tube here, but stays in the glass transition temperature until it hits the melting zone here, where it becomes liquid and it is ready to be extruded. After the plastic is extruded through the nozzle, it starts to cool and returns to its original temperature, which is the room temperature. And this is our final result. Now, keep in mind that most hotends have coolers attached to them in order to help the plastic cool faster after it leaves the nozzle. The coolers are the fans that I talked before, that I told you not to open the 3D printer when you put on the hairspray, okay? All right, now let's see some components of the hotend. First of all, there's the nozzle, this one, which as you can see is pretty small, which is the part where melted filament comes out of the hotend. Of course, you have to know that the size of the nozzle defines the resolution in the XY plane, and therefore the print quality of the whole print. Then there's a heater block, which joins the nozzle to the heat break and holds the heated cartridge and thermistor. Here are the imports of the heated cartridge and thermistor. So I think this is a thermistor. And then there's a heatsink which cools down the cold part of the hotend using a fan and lateral fins. It is made of mostly of aluminum to easily dissipate the heat through the fins. Hold time. So now let's do a small, let's stop a little bit so we can now all decide what's the right answer. The question is, which component is responsible for heating and melting the 3D printing material in FDM 3D printing? Is it the extruder, the bed, the nozzle, or the build plate? I'm starting the poll right now. Wait a minute. Stop. What? Relaunch poll. Okay, there it is. All right. So I'm expecting you to be right in this one, hopefully, because we discussed it right now. And the question is, which component is responsible for heating and melting the 3D printing material? So this is the key question. All right, I'll just wait half a minute more. All right, so I'm ending the poll. So let me share the results. Okay, most of you were right. It's the nozzle. Most specifically, it's the whole hotend, as we said, the whole hotend component. But of course, the nozzle is the right answer. The bed, of course, is not there to melt the 3D printing material. It works as a heating component, let's say, because it keeps the material in a standard temperature, but it doesn't melt the 3D printing material. And the extruder is the part where it pushes the filament to the nozzle, so it doesn't work as a heater or as a melter either. Maybe you got a little bit confused because the extruder with the hotend can be the same sometimes. All right. Let's close the poll and let's go on. So this is a hotend. This is a small video that you can see how the hotend works. Let's see how it moves to the X and Z axis. Here you see it manually moving. I think this is Julie moving the hotend right and left, this to the X-axis, so this is the X-axis. Also, this is the Z-axis moving up and down. So this is a manual way to move it on the Z-axis, move your printer on the Z-axis. And we also printed this part in order for us to make it easier to use the manual movement. You can also do it. There is many 3D printed files that you can find on the web that you can print them to assist your printer and make it even better, let's say. Maybe even more robust, or sometimes even make the printer more accurate. All right. Now, how are things moving? This is a small summary of what we said. Now, there is at least 4 motors on the standard FDM 3D printer. There's 3 motors, one for each axis, and then there is an extra motor for the extrusion. So basically, what the 4th motor does is it pushes the filament inside the hotend. How do they stop? Every motor has a stop switch at the end of their movement, and when it touches the switch, it stops moving. This way, for example, we don't program the 3D printer. If we don't program the 3D printer correctly, the motors will not spoil because they will always stop when they meet the switches. Now, apart from motors, in order for the components to move, we need belts, which will connect the motors with the hotend, and guides in which the hotend and the whole structure can move on. Let me show you a small video. So here you can see it moving on the Z-axis. So this is the motor. Is that it? Maybe. Okay, I think in the next slide we will see those components. Yes. So here you can see the stepper motors, the belts. This is one belt, another belt you can see here on the, so this is the Y-axis belt, the X-axis belt, and the Z-axis is moved through this linear actuator here. And not a belt. And I think we can see some switches maybe here. I'm not sure. Maybe I think this one is a switch, but oh, also this one is a switch. So imagine this component going through the whole x-axis until this point, until it reaches this point. And when it touches the switch, of course, it stops for you not to break the 3D printer. Okay. Now, probably the most important part of the 3D printer is the extruder. The filament extruder on an FDM printer is a part that extrudes the plastic filament in a liquid form, as we said, and deposits it on the printing platform. But by adding successive layers. Now, the printed head is made of many distinct parts, including the motor, the drive, the plastic filament, and the nozzle to extrude the plastic. Some 3D printers are now equipped with 2 extruders. This enables you to particularly to print 2 materials simultaneously in order to operate 3D prints with 2 colors. The presence of 2 printers or 2 extruders also allows support material to be extruded, which can be removed afterwards using the solvent. Most people, when they refer to the extruder, they are talking about the cold end. So this part or this part that you can see here. The cold end is the part that utilizes the rotation of a gear. You can see this picture. With the use of a motor in order to push a filament inside the hotend, as you can see also here and here. But the truth is that the extruded module includes both the cold end and hot end. Right now, in front of you, you can see 2 extruder types. So this is the first one. The left one is the Bowden tube extruder, which is the extrusion system here. The cold end and the hot end are positioned separately on the printer, and they connect through a tube. And inside the tube is the filament that is fed from the cold end to the hot end. And on the left, you can see a direct extrusion system. And the only difference here is that the hot end and the cold end are basically positioned together. Now, in this case, there is no tube. Of course, you push the filament right inside the 3D printer, the extruder, and start printing directly from here. So no Bowden tube here. So these are the 2 standard ways, and I think there is no other way right now that you can do it. All right, let's do a small comparison between those 2. The Bowden extrusion system has cleaner movements, meaning that since the cold end is not attached to the hot end, there are no vibrations from the motor or the cold end, which could end up, of course, to a bad print. Also, since you can place the cold end anywhere on the printer, we have the ability to create printers with larger bit volume. Now, on the disadvantages, we need a more powerful motor in order to overpass the friction inside the tube. But let's say this is not a much more powerful motor. It's just to bypass the tube. But the most important is that we have slower response times between the cold end and the hot end, and sometimes this leads to material complications and print failures. So that's why most of the new printers use the direct extruder, so they have less printing failures. Oh, sorry. Now, on the other side, we have the direct extrusion system, which is more reliable in terms of extrusion, as we said, and therefore in terms of retraction also. We need a less powerful motor since the systems connect together, and it works with a wider range of filaments with ease. On the cons, as we said, since the system connects, we have vibrations from the motor, and also it's harder to do maintenance since everything is together, and it's hard to understand where the problem is sometimes. Here we can see how the extruder functions. This is the Bowden system, by the way. So this is a Bowden tube, or else a Teflon tube. So the filament is at the beginning fed inside the cold end. The stepper motor rotates a small gear, as we said, which rotates a bigger gear, and with the held of a bearing, the gear pushes the filament inside the Teflon tube. When the filament reaches the hot end, it starts to heat and melt, and it is extruded from the system as liquid on this point right here. Now you can see how the extruder works here. So it pushes the filament inside the Teflon tube. This is a Teflon or else the Bowden tube, and from here it goes to the Hotend and starts melting on this point. So don't make this mistake, guys, okay? This is not this, okay? This is different than this. All right. One more question, real fast. What is the purpose of a build plate in FDM 3D printing? Number one, to hold the 3D printed object in place. B, to provide a smooth surface finish. C, to prevent warping of the print. D, to apply a protective coating. So, I'm starting the poll. Let's start answering, guys. Keep the answers coming. What is the purpose of a build plate in FDM 3D printing? As you remember, the build plate is where we print the model. So why do we need that? All right, we are on minute 1. So 30 more seconds, as I see most of you are again right. So good job. And 5, 4, 3, 2, 1, ending the poll. All right, so most of you answered that the purpose of the build plate in FDM 3D printing is to hold the 3D printed object in place. And this is the right answer. This is actually the right answer because, of course, as we said, what we want from the build plate, we want it to keep the standard temperature, so the 3D printed object doesn't fall apart or doesn't also warp. But as we said, and also the most important thing that we can do for the printed model not to warp is to use adhesion methods like glue or the hairspray. So this is the functionality, you were right. The two of you that decided to say that it is to provide a smooth surface finish, let's say that it provides a smooth surface finish just on the bottom, on the first layer of your print, but of course not all of your print. And the protective coating is also applied on the end of the printing process. So when you have already printed your model, then you can coat it. And we will see it on the final slides. You will see some coating methods. So keep that in mind. All right, let's move on. Extrusion problems. Keep in mind that the big gear we just saw should be positioned perfectly before every print. Because if the gear is loose, then the extruder will not be able to fit the filament to the hotend. On the other hand, if it is too tight, it may spoil the form of the filament, or even worse, it may break it. All these things lead to under extrusion problems, and your prints will probably look like this here or like this here instead of this perfectly printed model. So, and most of you that will use printers, it is 100% guaranteed that you will see both. All right, the control box. Now, this is the last thing that we are going to talk about before we see some videos, regarding the slicing. And no, we won't see actually videos regarding the slicing, but we'll see a lot of videos regarding the post-processing. The control board is responsible for all the electronic functioning of a 3D printer. Of course, without it, the 3D printer would not be able to do much more than just turn certain components on and off at a manual flick of a switch. Controller boards handle all the logic behind 3D printing, such as parsing G-code files, regulating temperature, and most importantly, controlling the motion. The latter is particularly important when we're talking about FDM and stepper motors, of course. So, in simple words, the control box is basically the brains of our printer, because from the control box we can do anything manually, like for example move the axis through the motors or heat up the hotend, or we can ask the printer, of course, to print something. If we see a problem, we can stop the printing process and restart it or resume it. Slicing guide. So here I'm going to show you real fast some slides regarding the slicing of a model. So as you may know, before printing a model, we have to use a slicer program in order for us to basically find the right way to provide the G-code to the 3D printer so that we have a perfect print. So now we are going to talk about the most commonly used slicer, which is the Cura slicer. Here you can see the first adjustment that someone can do. Of course, as I write here, it is very important to adjust some basic settings where you first open the program, such as adding your printer to the Cura slicer. So when you start first time the program, you will have to find your specific printer and include it on the slicer. And then the next step is to create some slicing profiles. As you can see here, the slicer already has some predefined profiles for those of you that don't want to create a custom profile. So you can choose from the standard ones. And you may also know here that the standard quality or standard profile is different from printer to printer. So if you, for example, find a video on YouTube that has different profiles here, don't be afraid. It's just because you have a different printer. But you will find yourself deciding to create a custom profile because maybe you want more accuracy or you want to change something regarding the temperature. Then you have to click here and create profile from current settings and then start differentiating your settings. Now, let's say that you have your STL file. The STL file, as you may know, is the 3D model file that you have designed or you have found on the web. You import the STL file and then you can manipulate it and bring it to the desired shape and position. On the left here, you may find some tools of the Ultimaker Cura. The first one is the move tool, so you can move it around. The bottom represents the bottom of your printer. So, for example, if you place it somewhere here on the left back of the plate, then the print will go here. And of course, you may understand that you can position it everywhere you want. You can also scale your model from bigger to smaller. You can rotate it. You can mirror it if you want to create a mirror of the model. And of course, you can use more advanced model settings. Now, one thing to note here is that the Ultimaker Cura also has add-ons, which means that you can actually search the add-ons of the Cura slicer, the more, let's say, capabilities of the Cura slicer in a way that you search, for example, the App Store on your Android device. There are a lot of add-ons, like, for example, apps that you can use to enhance your slicer and make it exceptional and do exactly what you want. All right, now, when we decide the profile, we have two options. We have the recommended settings, which is this tab, or I think it's here, no, yes, or the custom. This behind is the custom. Unfortunately, I didn't find, I don't have right now another tab to show you, but as you can see behind, you can see quality walls, infill, speed travel. So this is the custom tab that you can customize, let's say, your profile. And this is the recommended tab for those of you that are new to the hobby and you just want to print your first model. As you can see here, it's very easy to use because what you do here is deciding on the first one, which will be the height of your print, the percentage of the infill of your print. Here you click that if you want gradual infill, I would not suggest it. And of course, I would suggest to also include the supports of your print and adhesion on the bottom of the print. The adhesion is a special way. Oh, what did I do? Sorry, I don't know what happened. Okay, we're here. The adhesion is a special way to adhere the model. So instead of using, let's say, hairsprays or glues that we discussed about before, you can use this type of adhesion, which is much, let's say, easier because you don't have to do anything else. You just click on this button. But you use much more material when you print, because basically what happens is that you create an arc on the bottom of the model, a plastic arc, for it to stack. All right, now let's talk a little bit about the custom settings. So if you don't use the recommended settings, the most important things that you can change on the custom settings are the quality. So as we said, you have to choose the preferred layer height. So keep in mind that when you have a small layer height, you have better results regarding the accuracy and the details. While if you have a bigger layer, it's basically self-explanatory here, as you can see that you have a less detailed print. Except if you have, let's say, a cube. When you have a cube, as you can see, that nothing happens when you differentiate the layer. Then we can change the walls, the wall line count. So if you, these are the walls of your prints. So as you may understand, the more the walls, the more the strength of the material, of the print. So if you want your print to be strong, for example, if you want to give your print to kids, and the kids will play with it, if you don't want them to break it, then add a lot of walls. But of course, the printer will require more time and material to print it. Now, another way to make it strong is to make it have a let's say not a maximum, but a pretty big percentage of infill, like this print here, which is almost 100% solid. But of course, again, it requires a lot of time and material. As you can see, compared to this one here, which will print much faster. Oh, oh, it's the mouse. Okay, now I understand. Okay, so that's my mistake. And the last one is the speed. Now, I put the speed here on the options for you to not touch it. So if you don't know exactly what you are doing with it, don't mess with your printer speeds. Your printer knows how fast it can print. There is no need to doing something more or something less than what it does right now. In my opinion, you will need to have almost a year of experience of 3D printing before you start messing with your printer speeds, because basically you may destroy it, and we don't want that. Some other things, some other custom settings that you may find yourself experimenting with is the retraction. Here you can see this is not no retraction enabled. Now this is stringing. This is called stringing, and your printer, you want to print here is just this column and this column, but instead you also print those small particles in the middle. In order for you to avoid this, you can enable the retraction on your slicer, which helps avoid this stringing. And what retraction does is that it pulls the filament up when it stops printing, and it brings it down when it continues. Travel, of course. You have to enable avoid printed parts when traveling, so you will not hit your part when printing. And when you enable it, your printer will actually know that it will not go through your model. So it's a standard enabled key. Just check it out. You have to keep it enabled. Print bed adhesion, as we talked, this is the raft that I talked about before. Oh, no, this is not the raft. Basically, this is a print. Okay. So there are three basic types of adhesion. The one is skirt, which is the one that you can see here. So what happens here is that your printer prints a little bit around your print to be sure that you have leveled the bed right. The brim is the same one, but a little bit, let's say, thicker because it also touches your print. And the raft is basically a raft, like the words, the meaning of the word, which is a raft where your model starts printing. As you can see on this picture, of course, the skirt was not enough because we have warping here. We may also need some more hairspray or glue, or instead of that, we can use a raft, for example, to stick it better. The last one is the temperatures. Here you can use the recommended temperatures depending on the material that you use. So when you use PLA, for example, you may see the recommended temperatures on the spool. So there is no need to experiment with this one, I think. Maybe experiment on, let's say, the temperatures that your manufacturer already gives you. Most manufacturers give you a range, let's say from 200 to 210 Celsius. You can experiment on those between those two temperatures and find the best results for your printer. Oh, and the last one that I'm writing here is that when you change all the custom settings, please save the profile so that you can use the settings again in the next thing, so that you won't have to do the whole thing all over again. All right. Supports. Of course, there is a tab for supports. What supports do? The supports are these blue, let's say, particles here. As you can see, we want to print a salamander. I don't know how is this thing called. Chameleon. Yes, this is a chameleon. So let's say that we want to print this beautiful chameleon. But of course, you have your chameleon on the air. You need a way to print it. So you create these support structures on the bottom of the print, so that they can keep your print where it is. Now, there is two main ways to print to create the supports: the normal supports that you can see here, and the tree supports that you can see on the left. I suggest that the first time that you print, you go with normal supports to understand how supports work. But when you are familiar with supports, the tree supports are the perfect way to use supports, because what the tree supports do is that they go and touch your model where it should be touched, where it should be actually supported and start printing. Because here, as you can see, it is supported everywhere, but with the tree supports, you can actually find exactly where your print needs supports and not touch it on the whole model. Because when, as you may understand, this is plastic and this is also plastic. So when you take it out of the bed, it's much harder to detach it from each other. So this is the process. First, we slice it. We slice the model, as you can see here. Then we go to the preview tab. And this is the preview tab. So you can change here from 0 to the maximum of the layers. And so see, sorry, and you can see exactly how your print is going to go. So you can inspect your model, as I write here, and then you export it to a USB and print it. So the Prusa slicer is another slicer that I'm going to go through very fast. It's very close to the Cura slicer, but the Prusa slicer is created by the standard Prusa. Now, the reason I'm mentioning this slicer is because it has some advantages. It has some more tools like cut, arrange, etc. It has paint on supports, so you can add and delete supports manually and very easy. But this right now is not actually a pro for Prusa Slicer, because now you can do it also with Cura if you find the right add-on and experiment with. But the most important one is the configuration wizard, because based on the combination of your printer, the filament that you use, the material, let's say, that you use, and your print, you may the configuration wizard designs all the parameters for you, so you don't have to do manually the custom profile, for example. And I would suggest using the Prusa slicer if you have a Prusa product, just in case. All right. And now we start with the printing process. What do we need to do so we can start printing? So this is just a video of a printer. As you can see, it already has printed a part. We should first feed the filament, of course. So we have, as you can see, we need a robust stand. We open the printer. Let me close the sound. We go to prepare. Preheat. So right now, we actually preheat the bed to the right temperature. So in this case, it's 60 degrees, I think, 50 to 60 degrees. And we also preheat the nozzle, the Hotend. So when we have both of them preheated, we can feed the filament to the printer. Of course, you can also feed the filament just by preheating the nozzle, okay? You don't need to preheat the bed, but it's good to preheat the bed if you want to start the printing process after you import the filament. Oh, sorry. All right. Let's, come on. Why? Okay. Oh, wait a minute. Okay, here we are. I'm just going to, let me leave it here. So as you can see, this is the previous filament, I think. Let me see. Okay, here we are. As you can see here, we export the filament, the previous filament. because now the nozzle is heated, so it's liquid on this part, so it's very easy to export it. There is a button here that you push in order for you to export the filament easier, because it locks, of course. These are the sprockets that we talked about before. And you just take it out. That's how it looks when you take it out. And on this video, we put on the red filament now. All right. So keeping the temperature as is, our hotend is 200 plus degrees right now. So the same way that we export the previous filament, we import the new red filament inside the extruder. Push it through. And while you push it, you may see that from white it becomes red on the nozzle. And when it's fully red, the material that you export from the nozzle is fully red, then you are ready to start printing something else, something new. You see here, it's fully red. So we are ready to print. Okay, another video is leveling the bed. So for most of you, when you buy the printer, you will need to level your bed. And leveling your bed is not an easy process, at least for the first time. Now, what we have to do is again preheat, because we have to have everything on the temperature, on the printing temperature, let's say. So the temperature that you actually use while printing. And the process starts with you moving the nozzle to the bottom. So you home the z-axis. Let's see, like that. And you take a piece of paper, a standard piece of paper, put it between the nozzle and the bed, like this, and try to find the sweet spot between the nozzle and the bed. And the sweet spot is where the paper can go through the nozzle, so it is not stuck like you saw before. This is a much better way to show it. It has to go, as you can see, it doesn't go through. So we have to recalibrate. On this printer and most printers, on the bottom of the bed is the calibration sprocket. And as you can see now, the paper can move up and down, right and left. Okay, whatever. But it has to, let's say you have to find some how is it called? I will remember the word. Some resistance, yes, I remember. You will need to find some resistance when moving the paper, and this is a perfect spot. The paper, it won't be perfect if the paper doesn't find any resistance when you move it, because this means that it's over-calibrated, let's say. So again, here we try to calibrate the other corner of the print bed, of the printer bed. And this way we calibrate all four corners. And when we calibrate all four corners, then we can also calibrate the middle of the printer. And we actually restart the whole process again and again and again. The more times we do it, the best the calibration will be. So I would recommend not to do it just once. Of course, you have to calibrate all 4 points at least one time. In my opinion, you have to do it at least twice to be sure that you have calibrated your bed. And just so you know, there are many STL files that you can find on the internet that you can use and put them on your USB stick. And feed it to your printer so you can see if your printer is actually calibrated, if you did actually a good job leveling the bed. All right. So the last thing that we're going to talk about is the post-processing. What I'm writing here is let's make your 3D printing model even better. So let's make it look more professional. If the model, of course, is for functional use, then maybe we don't need to do anything more. But if we want our model to look even better, there are ways to achieve that. All right. The first we always do after print is removing the supports. So this is what I was trying to tell you before regarding the standard supports and the tree supports. This is how we see the model the first time we take it out from the printer. And those parts, those plastic parts, have to be extracted from the model. So we can use many tools to extract them. We can also use our hands to extract them. And as you can see, the next step is something like this when you extract them, or something like this. Now, there's many tools, as I said, to achieve that. And you can also smoothen your prints with these tools. My personal favorite is the rotary multi-tool, which is very simple to use and also very fun to use. Let me play the video while I'm talking. Now, as you can see, the tool uses a motor to rotate, and the only thing you need to do is attach the appropriate sanding attachment, and then you start the cleaning process, which may take from 1 minute to how many minutes you want. This is, let's say, not a standard procedure, so you can do it as much as you want to achieve the best results that you want to, depending on the design of the model, etc. And you can see what else I don't remember. Yeah, he just uses this finishing sanding tool to make the print smoother. Okay, of course, sanding. You can always use the traditional sanding methods. For the beginners out there, this is a great choice since the materials are very cheap and easy to find, and it is also very easy to do. In any case, I would recommend watching a video on YouTube before starting the process, for you at least who are total beginners. This way you will know what type of sandpaper to buy and how to do it without ruining your model, for example. Also, doing the sanding process manually, you can be more precise sometimes. Because sometimes if you have a multi-tool, you may choose the manual method instead, because a multi-tool is very fast and may ruin your model. So here I have a sanding video. So we will see a 3D printing model being sanded.
Okay, first things first, do not forget to put your mask on, and then we are going to start sanding with a 120 grit sandpaper. Again, the coarser grit to really help knock those lines down. Now I've wrapped the sandpaper around a sponge. It helps me have a better hold of it because you're going to be doing a lot of sanding. So if we take a look here, we can see that the layer lines, they're still there. Again, not a lot in these helmets, really cool, but we still need to knock some more down. And again, I'm still using the 120, and you can see the more you work that, the more you'll get rid of these layer lines so that you're not going to have to do a lot more of the finer sanding later on. So you can see here the layer lines are almost gone, and you're going to want to do that across the whole helmet with that 120. And don't forget to get into the cracks and crevices. Again, this is why I like wrapping the sandpaper around a sponge. The sponge is soft, and it really lets you get into all those little spaces to smooth that stuff out. Now, here we've done the entire helmet, and it's hard to really see much of a difference, but if you look, you can see most of those layer lines are really knocked down. Now we're going to go with the 220. Again, as we move up, the sandpaper gets finer, and it's still doing its job, and it's just making a smoother and smoother helmet. Don't forget, as you're sanding, because you can sort of forget about this, it gets away from you, to do all the little bits of cracks and crevices, because you don't want those to stand out. Now we jump up to a 320. Again, a finer sandpaper, a finer finish on the helmet, and again, you're going to do the entire thing. Of course, you're still wearing your mask.
All right. Oh, sorry. Okay, let's go through everything really fast. Go back where we were. Okay.
Okay.
Then the next stage of creating my model is filling. So we have to apply a filler material here. The most commonly used is the primer spray that you can see on the photo. This spray is also very cheap. I think it costs roughly 8 to 9 euros maximum, at least in Greece. And you can also use it multiple times. So basically what you do here is spray the model where you feel that you need to smoother surface. Of course, after applying the filler, you can use some sandpaper and do some extra sanding if it feels like it. So basically, repeating the process.
So even after all that sanding, there are still some layer lines. You can barely feel them with your nail, but they're there. So we're going to use some fillable, sandable primer for that. Key thing is wash the print before you use this primer. Now, I like to put it in a bath of hot water for a little while. This stuff is thick, that's why it's sandable and fillable, and this way it breaks it up and makes for a great mix, and it'll coat it really well. Now again, make sure you're not getting too close. Stand off, as the directions say, 8 to 10 inches so you're not getting any runs, and just give this a really generous couple coats. Let it dry, maybe even get it another coat to fill in all those layer lines. Sandable fillable primer is magic. If you look at this thing, you can see here almost no lines now in this helmet. It's going to have a little bit of grit to it. You're going to have to do some sanding after this, but those major lines are gone.
So as you can see, some major lines are gone, but some are also there. But we've already done a great job, right?
Sweet.
So of course you can repeat this process until you feel that your model is smooth enough. Just be careful because this process, since you sand, then fill, then sand again, you may sometimes hide some of the detail of your model, like those lines on the mask, for example. So yeah, be cautious.
Now, if you remember, we did have some thicker. To take care of those, we need to sand this sandable fillable primer so it is smooth before we go ahead and put on our glazing compound. And again, while you're doing it, don't forget, work in these cracks. We don't want them to fill up with the primer and the things we're using. Now we're going to go ahead and give this thing a wash. I wash the print multiple times during the process to get a lot of that grit off. So here we go. Here's some of those thicker layer lines. And this is when we're going to use our glazing spot putty. And I like to use a piece of foam because it really helps me get into the cracks and crevices when I'm working. And you're just going to go ahead and, you don't want to sort of cake this stuff on, but you want to put enough in there to fill those lines to make sure that when you sand this, you don't see them. And some people go overboard sometimes with this glazing compound. I am guilty of it myself. You really only want to use it when you're taking care of these really thick lines and some of the minor lines throughout the helmet. At the same time, if you really want to get that smooth surface, you might go through the whole helmet like I'm going to do and find areas where you can still see some lines and take care of those. Because the last thing you want to do is get to the end and get ready to start putting paint on or put the paint on and you start seeing some layer lines. Now, are there going to be a few layer lines here and there? Yes. I mean, we're going to do as best we can, but this is not going to be 100% perfect, but it is going to look pretty sharp. And don't be afraid to go ahead and get your fingers in there into all the little cracks and crevices to make sure it is taken care of. Here's an area I forget to do a lot of times, and it's the underside of the helmet. Go ahead and use your finger to fill in those little lines because that is something that I forget, and then you can see that in the helmet. Nothing's worse than forgetting an area like that.
If you can pause, the video. Have in mind that we should complete this presentation in about 2-3 minutes, okay?
Oh, all right. So
now, if you remember, we did have.
Let me move on at least to show you the final product. So this is the final product after the painting. And as you can see, we can also paint it with a brush or with a spray. So I would argue that this is a much greater result than the first one, right? After sanding and filling. Let's not do the poll, I guess, because we don't have the time. I just want to show you the techniques that we can use instead, let's say, of sanding. So these are the standard ones. As you probably know, PLA is not particularly heat resistant, which makes it not so great for outdoor applications. But it does mean that you can harness the impact of heat on the plastic to finish your prints. The most commonly used tool for this purpose is the heat gun, this gun that you can see here, which you can create very consistent results by placing the print on a turntable and spinning it slowly to evenly distribute the heat around the model, so it helps prevent over melting any specific areas. Now, another method is the epoxy resin coating that you can see here. Epoxy resin coating works the same way as the primer that we saw before. However, it's a little more difficult to work as you have to mix it before applying it to your print. Now, one thing epoxy performs significantly better than the primer is filling larger holes or print artifacts that have been left behind by the printing process. And finally, we come to chemicals. PLA can be smoothed with acetone in the way that ABS can, but there's still an option to achieve a similar finish. This Polymaker Polysmooth, this thing here, is composed of PPP, a material very similar to PLA that can be chemically smoothed. However, it requires the use of Polymaker Polyser, which is a box that dispenses isopropyl alcohol, which reacts with a filament to smooth the top layers. Now, I would say that you can stick to the previous methods. This is, let's say, the final boss when it comes to post-processing. When you start your 3D printing career, I would suggest the previous one, which are much easier and cost much less. So this was the presentation. Hopefully you all liked it and you learned something today. You carried something on your way home, if you're not home yet. And yes, of course, I'm open. Let me keep this one because it's more beautiful. I'm open to questions.
Thank you, Marco. As always, it's a really interesting presentation, very inspiring and very good information about 3D printing, both for software and hardware. So if you have any question, feel free to ask Marco. Don't forget, as soon as you enter this chat room, you will get a notification for the evaluation form automatically to your mails. However, I will put again in the chat room the link for the evaluation form. Thank you, George. And of course, all the webinars of the Move and Act project will be uploaded in a platform of this project. So you will also have the ability to watch again the recorded videos of this webinar. Later, we will inform you, of course, as soon as the platform will be ready. So I guess there is no question.
I also want to thank everyone. As I see everyone in the chat says thanks. So thank you for being here. And if there is any questions or you find something that you want to ask after the webinar, of course, we are here to answer any question. All right.
Okay, I guess, Marco, that's it. We don't have any question. So thank everybody for attending this webinar. I wish to all of you to have a good afternoon, and you always know that you can contact us and ask for any further information.